For today's video, we're going to do some example problems involving linear equalities. I'm going to give you 6 example problems. They're going to increase in difficulty, so the first few are going to be easy, the last few are going to be quite a bit harder, and we're going to go ahead and solve them. I'm going to attempt to show all of my answers as inequalities on a number line and using the interval notation. So I'll start off with problem number 1, which is going to be quite simple. All we want to do is graph and represent x is greater than 6.5. Okay, so what that means is we're going to show it as a number line, and then we're going to show it in interval notation. So to show it on a number line, I'm just going to have 3, 4, 5, 6, and 7. Obviously, my number line continues on and on in both directions. And we're saying here that x is greater than 6.5. So 6.5 is right between 6 and 7. So it's going to be right here. Since it's only greater than and not greater than or equal to, it's an open dot. And it goes in the positive direction because it can be anything greater than 6.5. So there we go. Now, in interval notation, that would be represented as 6.5, comma, infinity. And both of them have parentheses. Additionally, you could use 6.5 if you wanted to. It's the same thing. And that is the first problem. We'll move on to the next problem. Next problem gets a little bit more challenging. We're going to solve the basic inequality x, and I'm actually going to have to go back to using red here. X plus 10 is less than 5. And so here I want to solve it first, graph it, and then show it in interval notation. So I'm going to subtract 10 to both sides. I'm going to get x is now less than -5. And so now I need to represent this in my number line and in interval notation. So I'm going to have -4, -5, -6. Your number line can look different. That's fine. You can include more numbers than me. I tend to have at least one number to the left and one number to the right of the number that I am specifically looking for. I just want to show a little bit of depth and a little bit of clarity. But for simplicity, I don't need to start at 0 and then work my way all the way back. So x is less than -5. So I'm working with -5, so I'm going to have my line here. It's less than -5, so it's an open dot, and it's going negative. And so in interval notation, that is -infinity to -5. Keep in mind that we start with -infinity because it's the lowest number, and then we work our way to the right to the highest number, which in this case is just -5. Okay, we're going to get a little bit more challenging now for the third problem. We're going to have 4x plus 16 is less than or equal to 20. Okay, so to solve this one, I'm going to subtract 16 to both sides. I'm going to get on the left-hand side 4x is less than or equal to 4. Now I just need to divide both sides by 4. And on the left-hand side, I get my 1x, and on the right-hand side, I get is less than or equal to 1. Okay, drawing my number line out, let's say I have 0, I have 1, and I have 2. In this case, I'm going to be at 1, and I'm going to be less than or equal to 1, so that means it's going to be a closed dot, and I'm going to be going in the negative direction. My interval notation answer will be -infinity to 1. There will be a parenthesis on the side of -infinity since I can't reach that, but 1 I can include, so that has a bracket. All right, we're going to move on to problem number 4. And for problem number 4, we have an intersection inequality. And so we're going to have the problem 20 is less than or equal to 4x minus 10 is less than or equal to 30. All right. So from the previous video, when you try to solve these, whatever operation you do in the middle, you have to do to both of the left side and the right side. So I'm going to start by adding 10, and that means I need to add 10 to the left and add 10 to the right. So I'm going to get 30 is less than or equal to 4x is less than or equal to 40. Now I'm going to divide both sides by 4. So I need my green here. On the left-hand side, 30 divided by 4, if you work that out, I'm going to work it out quickly. It is actually 7.5. Because 28 divided by 4 is 7. 32 divided by 4 is 8, so you have 2 left over, and so it's 7 2/4, which is 7.5. You can also work that out by yourself. In the middle, I'm just going to have x, and on the other side, 40 divided by 4 is just 10. Okay. And so that is the inequality notation. We're going to do the number line notation now. So I'm going to have 7, 8, 9, 10, and 11. Now in this case, I have 2 specific numbers I'm going to be looking at, which will be 7.5, which will be right here. And then I'm going to be looking at 10. And in this case, we're saying that x in the center here, x, must be greater than 7.5, greater than or equal to 7.5, but must be less than 10. So in that case, it actually takes up this center area here, where it can include both 7.5 and 10. And just for notation, this is 7.5. Okay. So that is the number line notation. Now we'll do the interval notation. I'm going to have 7.5, which is my smallest number. 10 is my biggest number. And both of them have brackets because I can include both numbers. Okay. We'll move on to the 5th problem. We're going to be getting a bit more challenging here. Here we're going to have a union. Okay. So in this case, a union inequality, which will be, we'll start with -2x, and I need to make sure I write tiny because I tend to run out of room, is greater than 8, or x minus 10 is greater than 4. All right. To solve these, you can do them one at a time. That's what I recommend. So I'm going to start with the left side. -2x is greater than 8. I'm going to divide by -2. And so on the left-hand side, I still get x. Whoops, that needs to be in red. Sorry. I still get x, but keep in mind you're dividing by a negative. When you divide by a negative, the sign is going to change. And so this actually becomes less than 4. Okay? And so now I'm going to keep my or symbol. On my other problem, x minus 10 is greater than 4. I'm now going to add 10 to both sides. And I get x is now greater than 14. Okay, and so that is the inequality form of the answer. X is less than 4 or X is greater than 14. For simplicity, I'm going to use a number line here. And I'm not going to draw all the numbers out because I just don't have the room, honestly. But suppose you have 4 here, you have, let's say you have 10 here, and you have 14. All right. Starting with X is less than 4. It's any number less than 4, but not including 4, so it's an open dot. And then for 14, X can be greater than 14, but can't be 14 itself, so it's also an open dot going to infinity. Now, in this case, our interval notation is negative infinity to 4, parentheses, union, which is a giant U effectively, 14 to infinity. Okay. Especially when you're, and one thing to note, and this is just something I come across, when you're dealing with union inequalities, specifically the interval form, the interval notation tends to be one of the best ways to answer these. You have negative infinity to 4, union 14 to infinity. You can also do a number line, but if your numbers are very far apart, then it tends to not work. All right, we're going to have one last problem, problem number 6, and it's going to be quite interesting. So we're gonna write down this problem, then we'll go ahead and solve it. So we're gonna have 6 times the group of 2x plus free, and parentheses, is less than 4 times the group of 5x plus 7, and parentheses, minus 4. All right. So this looks a little complicated, but after we distribute all of our numbers out, distribute the 6 and distribute the 4 out, I think it'll get a little bit simpler, a little bit more simple. Sorry, use proper English there. So I'm going to distribute the 6 first on the left-hand side. I'll just focus on the left-hand side, then I'll do the right-hand side. We have 6 times 2 is 12. X. 6 times 3 is 18. I'm still less than. I'm just going to carry down what I have on the other side. Okay. Now that I've simplified the left-hand side, I'm going to simplify the right-hand side. So I'm going to distribute the 4 across. I'm going to get 20. Whoops. Let's do that way. I'm going to get 20 x plus 28 minus 4. And then I'm going to carry down what I have on the other side. There we go. All right. What I know I can do is I can simplify these two terms together. I can add them together. And then I can start to move terms left to right. So I'm just going to bring down what I have on the left-hand side. I have 12 x plus 18 is less than 20 x. Now 28 minus 4 is just plus 24. Okay. Now I can combine terms. So I'm going to take the 12x and I'm going to move it to the right. So I'm going to subtract 12x to both sides. On the left-hand side, I just get 18. let me make that a little bit better. There we go. Is less than 20 minus 12 is 8x. And then I have the plus 24. Okay. And so now I'm going to subtract 24 to both sides. And I'm going to get on the left-hand side negative 6 is now less than 8x. Notice that when you subtract a negative number, the sign does not change. It's only when you multiply or divide by a negative number that the sign changes. And so now the last step we have to do is we just have to divide by 8. So I'll divide by 8. And 6 divided by 8, if you can simplify that out as a fraction, it is actually negative 3/4. And so I get negative 3/4 is less than x. All right. Or in this case, I should actually say this. X is greater than negative 3/4. That's the proper way to say it. Not that negative 3/4 is less than x, but just that x is greater than negative 3/4. So let's go ahead and write this as a number line and then as interval notation. And so I'm going to get -1, 0, negative 3/4 is approximately right about there or so. And we're saying that x must be greater than negative 3/4. So it's an open circle, and it's going to positive infinity. Since it has to be greater than negative 3/4, we know that 1 is greater than negative 3/4. We know that 10 is greater than negative 3/4. So anything to the right is greater than negative 3/4. And then in interval notation, we have negative 3/4, comma, infinity. Okay, that was... Here we go. There we go. And both of them are in parentheses since we can't include them. All right, that concludes linear inequality examples. In the next video, we'll be going over equations in two variables. So, for example, y equals mx plus b, and we're going to start talking about y instead of just x.